Awesome. Well, welcome everybody. Thank you so much for joining us. I hope you are here to hear about residential energy management systems because that's what we are here to talk about. Um, as you might see from the number of fellow participants on this call, is a lot of interest in this topic. So we're really excited to bring this topic to you all and some really great experts here on our panel today to talk about um, energy management systems and electrical sizing and electrification and how all of those things work together. So just briefly starting with kind of the general assumption around electrification and electric readiness is that it requires higher panel capacity, greater electrical service to the building. And I think we're here to ask the question, do those actually require this? And I think our panelists here are going to tell you that, in fact, no, we do not actually need to see larger electrical panel capacities or bigger electrical services to buildings in order to enable electrification of homes or prepare homes for future electrification through electric readiness. So this panel is going to be talking about different aspects of that issue today. And so I just want to really briefly introduce our panelists here. Um, we have Stephen Kane from SPAN. Stephen has been with SPAN for, I believe, 3 years. Sorry, Stephen, one second. I'm going to actually, oops, sorry. I had something on the wrong screen. It was not working out for me. All right, let's share this again. Okay, sorry about that. We have Stephen Kane with SPAN. He has been in the energy space for over 20 years and has spent most of his career kind of describing it as electrician or electrical engineer adjacent. He started his career with this in the solar industry as one of the original co-owners of Namaste Solar here in Colorado, founding that in 2005. He joined SPAN in 2021 and started the service and support team there. He currently works with SPAN's home builder customers and sales engineering and operations functions. And he sees the move forward towards electrification as the best way to solve many challenges here in the built environment. So we're really happy to have Stephen here on the call. Next, we have Kirk Hammersmith. Kirk leads the National Energy Innovation team at Pulte Group, integrating smart energy technologies and intelligent load management into new residential communities. He brings more than 2 decades of experience across home building and clean energy with a builder-centric focus on electrification, grid resilience, and the homeowner energy experience. So we're really glad to have Kirk here with us. And then last but certainly not least, we have Justin Wilson. Justin works with the national and regional builders on new construction of residential and commercial buildings and forensic investigations on building sites all over North America to find solutions to problems in the building processes that affect energy, comfort, and durability. He also uses this insight to work with leading building product manufacturers on new product developments, product refinements, installation, and maintenance guidelines. So welcome to all of our panelists. We're really excited to have all of you, and I think we're going to have a really great, robust discussion here. So we're going to start off with Stephen, who's going to be talking a little bit about SPAN, the technology, as well as other energy management and load management technologies that are out there in the world. So I'm going to go ahead and stop sharing. Stephen can go ahead and share his screen here, and I'll kick it over to you, Stephen.
All right, is that working? Can everybody see? Oops, sorry about that. Slideshow. There we go.
Yep,
About now.
that's
Great.
great.
Yeah, thanks for having us, Adam. I think this is a really worthwhile topic to get into. I've been working with Kirk and Justin for many years, working with energy management systems, power control systems in the home builder space, and yeah, it's an exciting time. We're seeing a lot of different code kind of merging together, if you will. Energy codes in California have had these kind of requirements for many years under Title 24. California Energy Code out there. We're seeing it move into Colorado with the Energy Office new codes that are coming out this year. And we're also seeing a lot of, I would say, maturation in the National Electrical Code that supports these as solves for more electrification utilizing EMS and PCS. So yeah, a really, really great topic. So looking forward to what we're going to get into. Excuse me. So I have maybe about 10 or 15 slides. I'll try to be brief with a lot of the depth, but happy to answer any questions as they come up from the audience. And then we're going to have some Q&A time at the end as well. So here's a good QR code or link for those of you that haven't seen or dug into the Colorado model energy or model electric ready and solar ready codes that are coming out this summer. And we're going to get into some of the impacts on service sizing and electrical panel sizing for new home construction. In addition to that, in the spirit of sharing resources, there are some funds available from Excel that I'm not an expert on, but I thought I'd at least share some information about that that can help for some of the builders in the audience to support some of the costs that go into some of the new code requirements. So I encourage you to take a look at that as well. So generally speaking, yeah, we are seeing, electrification kind of becoming more the norm in the built environment. Also in the retrofit environment, we see a lot of electric vehicle adoption. Our cooking is switching over to induction, and our HVAC and hot water heating are also switching from gas to electric in a lot of different marketplaces. A lot of independent studies about how this adoption is going to impact the grid and how grid infrastructure relative to competition with data center and AI is in the news, almost every day. So surely the audience is familiar with these topics and what the general trend is. But we are generally concerned, like, well, we need to build the grid, or potentially overbuild it to support all of these new loads that are coming on. And I think I've recently heard our CEO, Arch Rao, talk about, how though there are concerns about the grid not being able to handle all this new demand. That's one perspective. But in another perspective, the actual utilization, the average utilization of our grid is actually quite low from a general daily peak capacity usage. So it's kind of a tug and a pull there where, we can build this grid to be for the worst case, worst day, or we can utilize, technologies that can kind of soften the impact with how we actually are a little bit smarter about how we use that grid. So as we're going towards an all-electric home, some of the new codes might start pushing us into 320 or 400 amp electrical service capacity based on classic NEC load calcs. In NEC 2023 and Article 220, we see, an addition of all these, 30, 40, 50 amp new loads, really putting a strain on the load calc and sending it over 200 amps. And, just to state on the front end, I'm not an electrical engineer. I definitely play the more practical application kind of perspective with a lot of this. And so the folks in the audience that are NEC code experts, inspectors, engineers, designers, et cetera, you guys are the experts, and, we'll look to you to how we're going to implement a lot of the details of how this works. But if you think about it in concept, we've got the electrical panel sits at the center of the home, and, it's really, aware of all of the electric consumption happening with all these just different loads at the same time. And so it makes sense to make it orchestrate, help it to coordinate coincident peak. I think that's the key phrase in a lot of this is coincident load. We often classically will design our electrical systems for just the worst case scenario where everything might be turned on at the same time. When in reality, it's really not how people operate their homes. It's not very common that all these loads will be on at the same time. And if there is an event where we're starting to come near the electrical service capacity, we can manage that. And it's a pretty rare occurrence. I'll show some data later in the slide deck about in our fleet of information that we've seen here at SPAN anyway. It's not really a thing that happens too often, but yet it's great to have this technology from a PCS and functional safety perspective. In the retrofit space, there are products that can handle this kind of on a single load perspective. There are circuit splitters and smart breakers and CTs and power sharing devices that are out on the market. So certainly SPAN is not the only stall for this. I'm very conscious of the fact that I'm grateful for the state of Colorado to share this webinar and platform, but there are other technologies in addition to SPAN that can help support this issue. But some of the questions that we would have or that we would raise or perspective we would share is that putting it at the whole panel level, the whole home level, sets a foundation for the homeowner to get more versatility out of their home over the life of that home occupancy. Everybody adds more loads over time. It's kind of the concept, right? Even though you bought that beautiful home that was perfect for you on day one, inevitably you might want to add a hot tub, add a pool, add a sauna, different loads like that are going to inevitably potentially exceed the capacity of what was designed originally. So there are ways to do it at the whole panel level, and that's our product. But let's dive into some of the code-centric language. that allows it and makes this code compliant and makes it safe for operation for functional safety. Looking back through the code cycle history, first EMS was brought into the National Electrical Code as a concept as far back as 2014, primarily for EV charging, right? I think the main application was to utilize a CT to put on the main service and then curtail just the EV charger if you were starting to exceed the capacity of the service. We hear a common use case from customers and people in the field that, a homeowner is really excited they bought an electric car. They come home, they want to install that EV charger, and they have 100 amp service. Their electrician comes out and says, you don't have enough capacity, so you need to trench up your yard or get a new aerial drop from the utility company and bump up to 200 amp service in order to install this 30, 40, 50 amp electrical vehicle charger. So there were some solves that started being put into the code back in 2014, and as we've marched through time, every year the code has gotten a little bit broader in how we apply different loads to this scenario. So now, as recent as the 2023 code, which we're currently under in Colorado, we can pretty much manage anything in the home. So from a functional safety perspective, we have paths in Article 220.70 and 750 that allow us to size the system such that we're able to manage loads and keep any overcurrent protection from tripping. As we look forward into 2026, and I'm the first to admit I'm still learning about NEC 2026, there's a lot of movement as far as articles and content in the code from 2023 to 2026. But the big kind of takeaway is that we've codified it under a section called PCS. And so that moved from Article 750 in the back of the book more forward towards the front of the book into Article 130 and has a lot more specificity around listing requirements and specifically UL 3141 for how power control systems will help us manage these loads. And I would share, classically power control systems before this code cycle were really about sources, right? So for any of the solar battery folks that are in attendance, we've used PCS, kind of to limit export, in places where the grid is oversaturated, if you will, with solar production. Think Hawaii, parts of California, some other places. There are non-export rules from the utility companies because the grid operators can't handle, too much solar with the classic and infamous duck curve, if you will, where overproduction of solar during the day and then, large loads coming on in the evening and that imbalance that could happen. But what we have in NEC 2026 really is codifying PCS for loads. And so now we have PCS for both sources and PCS for loads. And that combination just makes the umbrella for how we actually manage our homes in a more intelligent way. So what I'll do is I'll just reference a few of the NEC code in 2023 and how we apply it today. We've been utilizing this in California for many years, and Kirk can talk about how we've applied it to some of his projects out there. But yeah, ultimately we have a path in the code book that, Article 220.70 for our load calculation section lets us know that, as long as we are compliant with Article 750.30 and we are, following the definitions of an EMS, that the EMS shall be considered as a continuous load for the purposes of load calculations. So it's really just the set point, the maximum ampere set point. I sometimes share a funny anecdote. I got to go to an IAEA conference out in Bakersfield a few years ago of the 11 Western states, their jurisdictions out there. And, it's about 500 folks that are all, NEC code experts and inspectors. And, the main, one of the main guys stood up in front of the whole room and said, the concept here is at some point, the need for NEC load calcs will be diminished because we'll just utilize the software set point as the maximum ampere setting and the whole home looks like one load. So that's the concept here that we're moving towards. Moving over to Article 750, we do have some variables and some requirements for how you apply EMS in the NEC 2023 cycle. And there is it's about if the EMS is to be used as the limit to limit the current on a conductor, it needs to comply with these other subset points about how we do the load calc, how we handle system malfunction, and who's able to actually set these settings. one of the common questions is, can a homeowner just turn this thing off? And, technically it has to be a qualified personnel, which as we know in the front of the code book, that is, an electrician by, nomenclature and a qualified personnel that is not just, an average person or an average homeowner. And so it's really a password protected setting, and therefore it needs to be only accessible to those that are qualified. So these two articles link to each other, right? 750.30 talks about calculating the load per Article 220.70, and vice versa. Article 220.70 maps to Article 750.30. So feel free to dig into those and see how it applies. But we've been seeing it utilized in California for quite a while on lots of large builder production lots and custom homes. And I often get a lot of questions from engineers of like, how do I show this on my plan set? Like, what does this look like? And so I'm showing an example load calc here where, some of you that are familiar with some plans review activities, you've got multiple plan sets of different square footage of homes. And, even with future electric loads, you have to include all of these potential ampere loads within your load calc. You're coming, a net result over 200 amps, in this example, between 232 and up to 294 amps. But ultimately, noting that 750 and 220 article, you can just delineate the EMS set point on your plan set and determine that the service size can remain at 200 amps, even though the classic load calcs are coming in over 200 amps. So this is a pretty clean way to see it. I'm always up for input from our local Colorado AHJs and permitting departments, building officials, inspectors, how they prefer to see this on plan sets. But it's really it's been working well in California for many years, displaying it like this. So how does it work? What does it look like? When we talk about this topic a lot, there's kind of three framings. It's what is it? What is EMS? How does it technically function? Is it code compliant? And what's the homeowner experience? And so framing it in that way, you can kind of see that, we have this concept of a firm service rating as we start, adding more load, turning on the EV when you come home from work, kicking on, the oven to get dinner going. You start to reach that 80% threshold. So 160 amps on a 200 amp service. And ultimately, something needs to reduce its consumption so that we don't trip the main breaker. In this case, the EMS can either completely turn off a load by opening in a relay, or it could dynamically curtail it by communicating with an API. And ultimately, we keep the load on the service within bounds. So what does that look like through your permitting process? I would, offer that, it's really important that the products have the right listing. Again, 3141 being the one to kind of rule them all. Previously, we used, UL 916, and we had some language in, UL 1741 about PCS. But yeah, ultimately, these things should be included in your permit packs, and they should be listed on the equipment so that the inspectors, as classically they would, utilize UL listings as the way to comply with code requirements. That's ultimately the way that it is smoothest in the field. As far as the homeowner experience, we do have to consider, there's probably an upper limit to what occupying a home that is energy managed seems like from a good homeowner experience. And again, we've got, the firm service rating that it gets set in the settings by the electrician. But the homeowner, should have some agency over what's being curtailed when. And so we do see some applications where they can change the rank order of what's getting curtailed. But I would say that like 90% of the time, you pause the EV charger for just a few minutes, you can ride out these high power events, and a homeowner won't even notice a brief pause in their EV charging, or even a curtailed or dynamically ramped down amount of current to their EV charging. What we have seen in the field or in our thousands and thousands of installations out there is that these curtailment events are pretty rare, and when they happen, they are for a really short duration of time. We've seen in our fleet, in PG&E territory at least, that less than 2% of the fleet has a curtailment event, and they last less than 5 or 6 minutes once per year. And so that's across quite a wide swath of data gathering. And so we're glad that we have functional safety here, but we're also glad that we have a homeowner experience that is tolerable for how most people handle their usage. So I'm coming up on my time. I would just share a couple little anecdotes about some projects that I've worked on before I hand the mic over to Kirk. We have a project I've been involved in for about 4 years now, where the South Burlington, Vermont community has a project called Hillside at O'Brien Farm. This is an all-electric community supported by Green Mountain Power, the utility, and the developer. And they initially built these homes at 320 amps because they were worried that with two HVAC systems in cold zone 6A for heating and electric backup heat on those HVAC systems, that they were going to have a lot of curtailment. So they built them at 320 amp services. We would propose that they could build them at 200 amp services. And now that we have about 3 years worth of data, we have noticed that of all of the homes there, only four homes have ever exceeded 100 amp draw ever. And of those that did go over 100 amps, they didn't exceed 125 amps. So these are very large homes. They're very cold climates that have EV charging that are able to handle this service capacity just fine. So that's my shtick. I'll leave this slide up for Kirk to speak to, and we'll kind of go from there.
Excellent. Glad to be on this forum with all of you. There's a lot of you on here. So I wanted to thank the participation. There are so many questions and interest comments that I receive on the building side about smart energy management. I hear terms like load control, and usually we start looking from a builder's perspective. We start looking at what are our options when we start looking at the demand amps exceeding what a 200 amp service can handle, and that's exactly what caused the connection between Pulte and Span a couple of years ago. We had a community that that was requiring somewhere in the 230, 240 demand amp range, and it was going to dramatically impact our cost structure just going to a 400 amp service. The other thing that we've started looking at is in some situations, it may not even be practical for a utility to offer more than 200 amp service in certain areas, depending on land development and kind of timing and location of where we're building. So we really started looking at energy management and the smart technology with Span, and we continue to look at the technologies that are being offered by others as well. But we really started focusing on a community that we were building in California, and went down the path of keeping it at the 200 amp main service through Span, and started watching and testing and starting adding it to other communities. And so originally the thought was we're going to need to focus on any of those communities where that requirement to go over the 200 amp leg was going to be required. In California, we were, obviously focusing on the energy efficiency of the homes we're building to scale, and really driving toward that constant improvements, constant code changes. And when we started focusing on those types of things, full electrification became one of our focal protocols as we started building additional communities. And then we started seeing some agencies like the California Energy Commission and other agencies start to contribute to builders that are willing to address this through energy management, which caused us to start adding this technology into many of our communities in California. And now we're moving it into other divisions and developments across the nation. One is actually coming up soon in Colorado. So that'll be a nice entry into that as the code cycles change there as well. What you're seeing on this slide is the first version of Span that we installed in California. At the time, it was the previous generation Span. We had more circuit requirements as far as the number of circuits requirements for the home. So we wound up installing two of the span panels to work in conjunction with each other. And that's why you see that photo there with two span panels. Since then, we've started installing the newest generation of the span panel, which is more effective for us. It's one single panel that handles all of our circuit requirements. So there's a little bit of a change there. This community that you're seeing here, we've had the benefit of watching this community build out completely 100% from start to finish over about a year and a half time frame. And also not only collect the data or inputs from our construction team as we started installing this relatively new technology for us, but starting to get some customer feedback. And it's been positive. We haven't that I'm aware of had any negative comments from customers. Once they learn what they have in the homes that we're building with this type of technology, we start hearing more positive comments. The questions they ask are things usually centered around, what if I want to add this or that? It could be an EV charger. It could be anything that a homeowner might add to their home down the road after we close that home and hand the keys over to them. So that's the primary focus of why we've been installing the span. We have a lot of data that as a builder we've been able to pull in just from our interaction with our buyers. And we get a lot of questions from actually other builders. Hey, how has this gone? We're thinking about this too. So I'm glad we're having this discussion right now. Justin and I have had multiple conversations about this direction, this product over a period of a couple of years, where we brought all of our construction teams around the nation into construction instruction in Colorado with Justin. And in addition to all the other things that we discussed there, we did discuss span at that point. So at Pulte, we understand what this product is, what it does, what we're able to avoid. And we also see the benefits not only to us as a builder, but to our buyer and to the utility and the agency. So that is the direction we started going a couple of years ago, and it's worked out pretty well. We're down to really efficient wiring with span. We're starting to see our electricians fly through these installations. We're starting to hear comments like, wow, now that we've done these types of installations, we enjoy these things about this. And we hear a lot of those comments too, just from the builder perspective and from our trades. So that's really what I wanted to showcase in front of everyone. I'm open to the comments at the end of this. If there's any builder specific questions that you have on the implementation, how long did it take to implement, all those questions that I typically get, I imagine you probably have as well. So thanks for having me here. I'm going to turn this over to Justin. Mute.
Justin, you're muted. Yeah, there you go.
There we go. So I think this is a great discussion. I was reading some of the questions as well. And Stephen, I think a lot of these are going to be geared towards what you have already presented, and as well, Kirk, for you. Yes, so there is from CI or CI Live, our facility, a few things on my mind that come up, and there's the panel component, and then we really help builders, be it Pulte or others, look at the incremental loads that they're actually seeing on the building from heating, cooling, hot water. We focus on lights and appliances as well. And one of the things that we're trying to do and is to give builders that hands-on visual approach. So we worked with Span in this particular example here. Stephen came over, we installed the previous gen panel. Now we're about, I think Stephen's going to nod his head because he's on mute, but we're going to replace said panel that is a 32 breaker panel with a 48 breaker panel in the coming weeks, months. What we did in our facility is everything runs, and we actually run And that the point here is we want to gain an understanding whether it's a heat pump or its interaction with the heat pump water heater that you see in that slide photo to the right. We want to see the interaction between the panel and the heat pump water heater. We have two other heat pump systems connected to the span. We have car charging, so span drive, electric resistance heaters that we can ramp up, and really give builders, the point is, builders and us, a feel for what happens when we go into a in span situation is called a power up moment, which then I'm starting to actually shed some of these loads or do something with this, if you want to call it, our power control system. And in this particular example, Stephen came out with us. We had just gotten things running, but we're running two different heat pumps, a heat pump water heater, a mass amount of electric resistance heaters, and then looking at the interaction when we say, okay, well, we need to charge the pickup that's in the photo as well. And what does a span actually do when we're actually playing with that? And what it's doing is curtailing the amount of current going into the vehicle, or telling you altogether, I'm gonna stop charging the car, and doing it sort of seamlessly. My point is, all these things are part for us as the builders. As Kirk said, they come to our facility. We want them to actually see it. We've installed it. We can run the systems up and look at other things. EMS is and power control systems are one component of it, but I said I'm going to focus a little bit more towards enclosure technologies and things that we're working on over at our facility with either manufacturers or some of the builders, and what their end goals are. One of the key things that we're looking at is integration of span, but other things like heat pump technologies. And there's a big component that's going along with it, but I'm going to say the other side of this is the enclosure of the box, the new requirements for insulation, for air sealing, and how do we optimize that building so that we've got a very balanced cooling load and heating load. They're two of the biggest drivers that we have in the building, or a typical residential house. And things that are growing are also hot water loads in the building. And the challenge is, okay, and I was taking notes when both Stephen and Kirk were speaking, you know, yes, so we go from the situation where it's not necessarily what I can see. If we're right sizing things in the house, mechanical systems, heating, cooling, hot water, lights and appliance loads that are controlled in the building, and having a pretty good understanding on them, it's looking at the areas that require, in my opinion, extra breaker space in the field that we work in. Is okay, we have a heat pump. We have a cold climate heat pump. Um, in Denver, you have to say, if you have a cold climate heat pump and you pick the right one that's complementing the right enclosure, so the heating and cooling loads are relatively balanced based on the insulation levels, air sealing, and windows that you've chosen. Does the heat pump need backup heat? This is where I'm going with this. Meaning, do I really need with a heat pump a 40 amp breaker that's emergency or backup heat on a system that's designed and manufactured to deliver 100% of its heat well below 5 degrees Fahrenheit, which is crossing the design temperature for most of the Front Range of Colorado? So it's breaker space, and that's why I saw with Kirk two panels, because it wasn't about the ampacity the house required. It was about the fact that we add car charging, we add backup heat, we add this. There's a heat pump water heater, and so it's not necessarily about the load on the house. It's that I need 40 or more breaker spaces in a typical panel to have, was sort of my note, breaker capacity more than electrical capacity of the building, because there's so many different things that may or may not run at any given time. Or my point is, there are times where we're adding things to the building where they're truly not necessary. I'd throw this backup heat for a heat pump in there. Why don't we have backup heat on a gas furnace? Because if a pressure switch goes out, the system won't fire and it won't ignite. You will have no heat source in your house. Same as if the power's out, the fan won't run, other things like that. So we don't do it typically with other appliances that we're used to. So that's my first point, is if we size it right. we do a lot of work our firm does with Canadian builders, and Canadian builders are electrifying at a high rate as well. Um, it it's interesting that we're looking at the term differently, saying, okay, it's in Winnipeg, Canada, which is far colder than Colorado, pretty much anywhere here in Colorado, probably in line with Gunnison, but longer intensity and windier. They're looking less at it and looking at supplemental heat, or what is the balance when a heat pump starts to lose its capacity that I only make that amount up. So we're just supplementing that difference. Maybe, and the difference here is maybe it's spun off of a hot water coil that's connected to something else. Um, Maybe it's only a 3 or 5 kilowatt heater that requires a 10 amp, 15 amp breaker to run it. So there's a bunch of differences that we're starting to see, is my point. I think I want to turn it over more towards questions, and I don't know if Stephen and Kirk kind of want to wrap this one out with me together. I'm going to leave it as one other thing is in other markets it's happening. And I said in Canada, for example, I know Pulte is actively looking at electrification throughout multiple markets in North America. We have other production-based builders. One I was looking at their list, and they're in 22 markets. It's not Pulte, but they're in 22 markets. They're zero energy ready homes in 100% of their markets. And I looked at their listing this morning, and they're using heat pump technologies in all but one. So in 21 of 22 cities that they're building in, they're using heat pump technologies, both from water heating and space heating, space cooling, and looking very quickly at things like solar integration. And I think there's a good discussion here about how does an EMS deal with solar integration, Stephen, and how does battery systems, battery storage, which are becoming very prevalent in homes, how do those play in this sort of triangle, quadrangle of when I add a vehicle to this thing as well? I think that's a piece that we've got to kind of dive into and think about.
Sure. Yeah, I'd be happy to riff on that a little bit. And then maybe Adam, I don't know if you want to play moderator and pick which questions we have time to get into. There's a lot of really great dialogue in the Q&A.
Yeah.
Yeah, I mean, I would share, Justin. Yeah, obviously EMS can work with or without solar and battery, right? Like you can have just an all electric home or a mixed fuel home and still utilize EMS, whether you have solar landed there or not. And then, in a battery storage scenario, like we see on Kirk's homes that are standard in California, because of their CEC requirements, they work pretty seamlessly. And I would go back to that, concept of PCS for sources and PCS for loads, and how, classically we weren't, necessarily marrying them, but that is how we have to orchestrate this in the future, right? And that's the way that the listings are moving, the UL 3141, UL 1741, and then, what we're doing in the National Electrical Code. And so having the language and having the compliance path for all of these equipment manufacturers to then build the gear towards is really how we can have optionality for all of these builders. Not everybody wants solar, not everybody wants battery, but when you do have it, how do we utilize it in a homeowner friendly way, and in a way that makes the house, both comfortable and functionally safe. And I
Yeah.
would say that, yeah, when we see the sources contributing to the bus bar, let's utilize that energy. Let's not pull from the grid, right? We save costs, we save demand on the grid side, and it ends up being a better use case for both sides of that meter.
I like that. I think my side of this is installing it, working with electricians on, so we installed it in our shop. And we also have one of our employees has a Savant system in their house running all types of things, including a Tesla Powerwall, and they've got 2 EVs. But installing in our shop, like everything else, is operational. It gives us the opportunity to kind of dig into it, troubleshoot it, look at it, learn more about it. Um, and the first, I'm going to give some just general comments. One is, Stephen, I learned from you just after we had it installed, is that it's it's really controlling things that happen from the point of power entry to the house and thereon. It's not
Mhm.
communicating backwards. And that's an important component at this point, I think, to sort of reiterate that it's everything from the homeowner side. The other is I love that we can restack things in prioritization of what stays on versus what gets turned off. Um, though that rarely ever happens, as we've learned. And Kirk, I think there's some notional stuff and things that you were testing in California of how hard it is to actually get up to 200 amps draw into a house. We actually have our system in our shop with multiple things connected so that the events are happening differently around 50 amps of draw, which we're able to. I think we have 50 or 75 on there, Stephen, but we're able to kind of tune the panel down so it's shedding power. And the main thing is that this doesn't require a lot of homeowner interaction, and that's what I like about it. That things are very seamless. You can play with it if you want to. I'm very techy, as many people on this call probably are. Then you can move things around and prioritize what you want in that stack. But the other side is it's mainly communicating on the homeowner side. It's doing it behind the scenes based on what their actual use patterns are. So there's just some smart to it. So I love that aspect of it. Kirk, I think it'd be great for you to talk about some of your trials in an actual house and what you guys experienced.
Sure, I'd be happy to. For the benefit of those that would like to know what it's like to start using Span, we had those same questions. So we elected to install our first Span system in one of our model homes. It was one of our larger model homes that definitely, in fact, we're showing it there. It's on the bottom left with the Tesla in the driveway. You'll see on the back wall there a Span Drive EV charger, EVSE. If you look just inside the garage on the wing wall on the left, you can barely see it. There's a Powerwall 3 right there. There's a gateway to the right of that. And then beyond that is the two Span panels, which you can barely see. This is a fully 100% all electric home. This is about a 3,600 square foot home, 6 bedrooms, 4.5 baths, induction cooking, heat pump space, heat pump water. We simulated homeowner loads by dropping in 1 or 2 space heaters in every room. And my job was to try to find the things you never know what you don't know, is what I told Stephen. And we're going to figure out beyond testing what our homeowners' experience would be. And I wound up doing a long-term test on this for about a year on this home. And the initial testing was with a set point of 200 amps on the system. We tried to demonstrate if we activate everything in that home, including EV charging, which, by the way, we didn't install 20, 30, or 40. We did a 60 amp level 2 there. So we maxed everything we could and started boiling water and doing everything that a homeowner might do. And we watched how the Span reacted. And then we noticed that it was very difficult to get to a point where the system would start to either shed load or throttle load. And we wanted to demonstrate that so that we can figure out what the experience was like. What happens? What do we feel? What are the things we don't know? In order to get any consistent testing on that, we had to manually adjust the set point of the Span down to 125 amps just to get things to throttle and to start seeing real time what Stephen was showing on that animation when you start turning on the oven and things. So that really showcased how much the capability of our electrical system is being underutilized, and how the technology can work without causing a negative situation with a home buyer living in that home. It's actually turned out to be very positive. We start having home buyers tell us things like, wow, we wanted to add a spa, or we wanted to add a wine chiller, or we want 2 EV chargers. And they didn't have to go back in and rewire our entire electrical system. They got to contact the electrician that installed that Span and add additional loads. And the Span continues to manage the entire house, even with their new installed equipment that goes beyond the production home that we built. So everyone that has touched this community in this house, our electricians, homeowners, other builders have come by to this home to take a look, and experience it, have had positive remarks. And when you're done here, I'd be happy to answer any other questions about that.
Yeah, thank you, Kirk. I think we have about 13-ish minutes left, so I want to jump in. We got quite a few questions coming through here. Kind of been perusing through, and I think one thing I'm seeing a consistent question on, and I think Stephen and Kirk, this might be kind of a main question for you, is what is the incremental cost difference looking at incorporating a span type of system into a home relative to a 320 amp or a 400 amp panel? And I don't know that the attendees have been asking this element too, but what is also the cost implication considering the utility side costs that are passed on to builders and homeowners for upgrading service? I think we really have to consider both the building side of the cost, but also the utility side of the cost that the homeowner ultimately bears. So if one of you or both of you could speak to that, I think that would be really great.
Yeah, I think I can speak to kind of like a broad national perspective, and then maybe Kirk can utilize some examples specific to some of his projects. But I would say there's no set answer, right? Like, all building codes are local. Also, all utility costs are local. We have found in some markets it can be, $3,000 to $12,000 per lot to bring in 320, 400 amp service. We find in other places, Tennessee and in the Midwest and places out east, there is no net difference to a builder or a customer to go from 200 to 320 or 400 amp service. So it's really site dependent, and it's not just one particular utility. It might, it all depends on the transformer in that neighborhood. It depends on, the utility infrastructure and what's happening with shared trench design and what capacity is already existing in the transmission and distribution side of the grid. So it's really relative to every project. And so there's not one set answer. I would say, generally speaking, at least what the costs that we know of that are kind of more controlled and known, think about from the meter back interior, you're not setting a 400 amp panel. And the delta between a 400 amp meter main and a 200 amp meter main might not be huge, but there are some labor costs. There are definitely some coordination issues, maybe product availability issues to consider. And so it's not a slam dunk. And I would encourage everybody that develops projects to inquire with your design teams and with your utility partners, both scenarios, and use that input to help you decide whether the cost benefit analysis is there. I'm not saying that this product or any EMS product is a economic slam dunk for anyone on the build timing. I would suggest, though, that it does give more agency and flexibility for the occupant of that home to do more things later, right? So if you were to build even that 320 amp service, there's some upper limit to that as well. And right. And so including some EMS and PCS, even on these larger builds, like there was a question about, 10,000 square foot homes, you allow, a 20, 30, 40, 50-year life of the occupancy of that building to have more flexibility with what they do with it and the different ownerships that exist over time. Kirk, what would you share?
Yeah, I'll jump in here on this. So from a builder perspective, obviously, we really focus on, cost and justification of that to acquire the benefit. And everything I've been speaking about up to this point has been about the benefit to the buyer, the people that move into these homes. So adding a 400 amp service, there's obviously a cost delta between a 200 and a 400 amp service at a home. There's also a little bit of cost going from the street up to the home, and then the trench. That really varies depending on the area, the municipality, a lot of things. The first one that we started looking into wound up increasing our per lot cost if we didn't do span by around $5,000 a lot. So Stephen, when you say that there's a range between basically 0 to, I've heard as high as 15,000, but what we've experienced is somewhere in the $2,500 to $5,000 range in the areas that we're building. The other side of this is in one of our other divisions in the Arizona area, we wound up in a situation where a community was looking the load calcs on some of the plans that were going to be put in this community would exceed the 200 amp service limitation, and the utility didn't have the capacity where we were building to provide more than 200 amps. There was other things going on that prevented that. So we had to make a decision. Are we going to limit our home that we're building for our homeowners to what would cap that 200 amp service capacity? Or do we move into new technology to address this? And it was that was one of the eye-opening experiences. It's not just about the cost. It's not just about the additional upgrade cost, although that does play a big factor into what are you offsetting in cost when you install a smart energy management system. That's how we approach it. We do not install energy management systems in all of our homes that we build across the nation. We have installed them in California and starting to install them in other jurisdictions where the code base and full electrification warrants looking at this type of technology. Um, we don't install this in every home in California, but we do have SPAN and energy management systems going into many of our communities that do not approach that requirement to move to 400 amp service. And that honestly is due to like Energy Commission or other agencies contributing to the builder toward full electrification, a lot like I'm seeing Colorado talk about and other jurisdictions where code changes are starting to push the load requirements up.
Awesome. Thank you both. I think that's really helpful. I think that addresses like maybe half of the questions here in the chat had something to do with cost. I think one other additional layer that I wanted to explore, and I think I've seen a couple of folks talk about this, is what are the implications for existing home panel replacements? I think your point, Kirk, about running into situations where the utility is not able to provide upgraded service for a lot of these areas. I think that is also a big challenge what we deal with in our existing communities. I mean, I can say here in Colorado, in a number of our communities, there are limited capacity, utility capacity constraints for those, entire neighborhoods, entire municipalities, and wondering what the implications are potentially for the utilization of these systems in existing homes.
Yeah, I think I might share a perspective that we're seeing, in other vendors like us. We're not the only players in the market that are seeing from the utility space, where everybody is seeing this electrification trend. There are some products on the market that are at the meter that allow for maybe a utility operator to help manage on a neighborhood level, right? A virtual service limit, if you will, or something that can make a home electrification ready and then therefore also not have to upgrade all the transformers, poles, and wires in that neighborhood as more people adopt electric appliances and loads. I would also say, to my earlier point about the use case of somebody buys their new car and they're very excited and they want to get their level 2 charger only to find out that their home in Arvada or in East Denver or in the Highlands have, a capacity of 100 or 125 amp service. And if that is underground, that trenching project, could be considerable in cost. And so the offset or delta of the technology cost versus the project cost becomes pretty apparent pretty quickly. And then also just enables them to then, that was their first electric device purchase was the car. And really over time, what we've seen our installers have to navigate with their customers is, this electrification journey is generally like one project at a time over many years, right? And so if on the front end, your very first project, you install an EMS system, now you've enabled that house to adopt different technologies and electrify more over time without, again, having to ask for the utility to bring you a larger service. And I'll just go back to the fact that every project is unique, and it kind of depends on what's happening in that neighborhood.
Yeah, absolutely. And I think one of the things that we've seen that's been a real challenge with that kind of incremental integration of electrification is that at some point, one home ends up breaking the back of the electrical distribution system, right? And who bears the cost of that? And obviously the the state and the legislature have tried to tackle that in different ways. But I think that, the integration of energy management systems in this context also helps to avoid those kinds of scenarios for more folks who are considering integration of those technologies. I think a theme that I've seen in some other questions here in the Q&A has been around, the NEC does allow kind of that 15-minute incremental measurement of load and calculation of load based on actual observed data as opposed to just, traditional load calculations in the way that we know them today. Can you speak to a little bit why, I think there are some questions about like, why don't we just do that and have a traditional 200 amp panel and evaluate the actual load based on measured data as opposed to putting in a smart panel? Can you speak to like the different situations in which maybe the 15-minute evaluation makes sense, whereas the load management system makes sense?
Yeah, absolutely. I mean, again, obviously that would have to be in a retrofit scenario where we have,
Right.
historical usage to examine. And in the new construction world, it's modeled, right? And so that's not that 220.87, I think, is the reference that somebody might be referring to, of using green button data if it's available from the utility company, or measured data from a monitoring device. I think it's great. I think it's a great solve. And it kind of proves out the use case that classically our NEC load calcs are kind of conservative, right? And we don't necessarily utilize that full pipe. So I would say there are absolutely use cases where actual real world data might just prevent that service upgrade. But Justin, what do you think?
Well, I had a couple of things. One is that I was reading through the comments as well. Probably most of the people on here know that, for example, I'm going to talk about your product for a second. There are breaker technologies, and then SPAN is a non-breaker technology. It's a panel technology. The SPAN panel utilizes standard breakers that your electrician is used to using, a square D or whatever that might be, that snaps into that standard bus bar. So that's just one clarification. The other I see is there are smaller panels if we focus just not on 200 amps. Maybe a house has a 100 amp panel. Does SPAN have a 100 amp panel, or is there one on the way?
You can downsize any of our panels to the breaker size that are classic trade sizes on the main. So 100, 175, 150, 125, 100. So it same form factor with the large bus rating can apply to any service size with a main breaker swap in the field.
Yeah. So then the other thing that I see is future casting when we start looking at variable speed heating and cooling equipment as well as domestic hot water equipment. It's about homeowner savings here, and it's about making it easy for them. And I see this in the future. And I'm just going to give a glimpse because Stephen, you can just nod or not, or just turn around. But what we're going to look at are the ability to automatically divert peak load costs from homeowners when they're unaware that they're under peak load conditions doing heavy electric requirements like vehicle charging, or under heavy cooling or heating days, or water heating. I'll give an example. A heat pump water heater has a compressor on it and electric elements in it. You actually have the ability in this case to say, all right, can I actually, in the future, this is happening, and can I actually say, rather than running a 230 volt, 4,500 watt electric resistance heater in a water tank, can I just leave the compressor on and not allow that to go on because the homeowner is about to incur a couple dollars worth of electricity? And the answer is yes, that's coming, right, Stephen? That's something that's future wise, and that's what we're looking at, is how do we, without homeowner interference, save them money, but making it easy for them.
Awesome.
Yeah, automated peak demand, prevention, if you will. Yeah.
Yeah. Well, I think everybody on this call knows we could go on to this topic for another few hours and answer questions and have discussion. So unfortunately, we don't have another few hours. So Stephen, if I could ask you to stop sharing briefly so I can just put up all of our emails here on the screen. We will also be noting down everybody's questions in the Q&A that did not get answers, and I'll pass those along to our panelists to see if we can get answers to those questions. But I would also encourage you, if you have specific questions for Stephen, Kirk, or Justin, to please also feel welcome to reach out to them. I'm sure they will be more than happy to address your questions or give you any additional information that they are able to do. Now that we are a minute over, I would just like to really thank our panelists, Stephen, Kirk, Justin. It was really a pleasure having this conversation with you and learning from your experiences and your knowledge. I'm sure that our audience greatly appreciates your time as well. And thank you all to our audience for joining us and taking the time to learn more about this. We really hope that this has been helpful to you and that this can help evolve our system and discussions around electrification here in Colorado in a positive way and address a lot of the challenges and concerns that folks have been running into with our new building codes and other programs trying to drive electrification, as Kirk acknowledged. So thank you all again for attending, and we will make sure this recording and slides are available to attendees and the rest of the public after the webinar.
Thanks,
Awesome.
everyone.
Thanks so much, everybody.